So we're told that f of x is equal to x over 1 minus cosine of x minus 2. And they ask us to select the correct description of the one-sided limits of f at x equals 2. And we see that right at x equals 2, if we try to evaluate f of 2, we get 2 over 1 minus cosine of 2 minus 2, which is the same thing as cosine of 0. And cosine of 0 is just 1. And so 1 minus 1 is 0. And so the function is not defined at x equals 2. And that's why it might be interesting to find the limit as x approaches 2, and especially the one-sided limits. And if the one-sided limits, well, I'll just leave it at that. So let's try to approach this. And there's actually a couple of ways you could do it. There's one way you could do this without a calculator by just inspecting what's going on here and thinking about the properties of the cosine function. And if that inspires you, pause the video and work it out, and I will do that at the end of this video. The other way, if you have a calculator, is to do it with a little bit of a table like we've done in other example problems. So if we think about x approaching 2 from the positive direction, well then we can make a little table here where you have x and then you have f of x. And so if we're approaching 2 from values greater than 2, you could have 2.1, 2.01. Now, the reason why I said calculators, these aren't trivial to evaluate because this would be, what, 2.1 over 1 minus cosine of 2.1 minus 2 is 0.1. I do not know what cosine of 0.1 is without a calculator. I do know that cosine of 0 is 1. So this is very, very close to 1 without getting to 1. And it's going to be less than 1. Cosine is never going to be greater than 1. The cosine function is bounded between -1 is less than cosine of x. I'll just write the x there. I don't need the parentheses, which is less than 1. The cosine function just oscillates between these two values. So this thing is going to be approaching 1, but it's going to be less than 1. It definitely cannot be greater than 1. And that's actually a good hint for how you can just explore the structure here. And then you could say, all right, 2.01, well, that's going to be 2.01 over 1 minus cosine of 0.01. And this is going to be even closer to 1 without being 1. So this could, but it's going to be less than 1. No matter what, cosine of anything is going to be less than, it's going to be between -1 and 1, and it could even be including those things. But as we approach 2, this thing is going to approach, 1, I guess you could say approach 1 from below. And so you can start to make some intuitions here. If it's approaching 1 from below, this thing over here, this whole expression, is going to be positive. And as we approach x equals 2, well, the numerator is positive. It's approaching 2. The denominator is positive. So this whole thing has to be approaching a positive value, or it could become unbounded in the positive direction. As we'll see, this is unbounded because this thing is even closer to 1 than this thing. And you would see that if you have a calculator. But needless to say, this is going to be unbounded in the positive direction. So we're going to be going towards positive infinity. So these two choices have that. And we can make the exact same argument as we approach x in the negative, or from below. As we approach 2 from below, I should say. So that's x, and that is f of x. And once again, I don't have a calculator in front of me. You could evaluate these things at a calculator, and it will become very clear that these are positive. And as we get closer to 2, they become even larger and larger positive values. And the same thing would happen if you did 1.9 and 1.9, and if you did 1.99. Because here you'd be 1.9 over 1 minus cosine. Now here you'd have 1.9 minus 2, so this would be negative 0.1. Let me scroll over a little bit. This second one would be 1.99 over 1 minus cosine of negative 0.01, 0.01. And cosine of negative 0.1 is the same thing as cosine of 0.1. Cosine of negative 0.01 is the same thing as cosine of 0.01. So these two things, this is going to be equivalent to that. That is going to be equivalent to that. And once again, we're going to be approaching positive infinity. So the only choice where all of that is true is this first one. Whether we approach 2 from the right-hand side or the left-hand side, we are approaching positive infinity. Now the other way you could have deduced that is say, okay, as we approach 2, the numerator is going to be positive because 2 is positive. And then over here, as you approach 2, cosine of anything can never be greater than 1. It's going to approach 1 but be less than 1. So if this is less than 1 as x approaches 2, it becomes 1 when x is equal to 2. Well, then this right over here, 1 minus something less than 1, is going to be positive. So you have a positive divided by positive, so you're definitely going to get positive values as you approach 2. And we know, they've already told us that these are going to be unbounded based on the choices, so you would also pick that. But you should also feel good about it, that the closer that we get to 2, the closer that this value right over here gets to 0, and the closer that this value gets to 0, the closer we get to 1. The closer we get to 1, the smaller the denominator gets, and then you divide by smaller and smaller denominators, you're going to become unbounded towards infinity, which is exactly what we see in that first choice.